Hi guys, hope you all had a great weekend and I hope you are ready for Monday's exam. Yay, I know everyone is happy. Anyway, so I will give you a short review session. This won't take more than 5 minutes. Simple to take you through the questions and through the exam so you know what to expect briefly on Monday. So there will be three sections of questions. Section one with multiple choice, each of them is worth 2 marks, sorry. Section two is with short snappers from 21 to 25. So marks are variable. I have some questions that are 6.25, the other one that are 7.5, and those easier ones that are like 2.5. I wrongly call this section short snappers because actually it's expected from you to write a lot. Of course, not on 5 more papers, but try to write in the space provided, or maybe you can ask for a new paper. But it's different. Like, for example, those that are 2.5 marks, you need to write less than for those that are for 7.5 marks. Last but not least is the question 27, which is the only one in section 3, and that is analog to the essay question, just it's not really an essay, it's filling the gap. So what can you expect in section 2? So there will be more questions, there will be multiple choice questions from units 1 to 5, but very easy one, but I have some multiple choice questions for units 6 to 11. However, written portion is mostly up from unit 6 to 11. So what would I expect you to know based on the questions that I created? So knowing differences and similarities between penicillin and vancomycin. So what is the target? Remember what's the target for these two antibiotics, but how the mechanism of action is different. Again, the target is the most important. Once when you know what's the target for these two antibiotics, you will understand what I'm asking. The role of mean E and mean D, which are two molecules that are creating pre-divisome. So again, FTSE is the main one, while mean E and mean D are controlling something else. So know who lead oscillations and who oscillates versus mean E versus mean D. Glucose transport system in microbial cell, I will just say the key word here is phosphorylation. What is phosphorylated and when and how glucose enters the cell. Fatty acid synthesis, so what's the difference between saturated and unsaturated fatty acids, and what's changed in enzyme and those cis versus trans bond. Differences and similarities between transport systems with a hint on T5 versus T2 transport system. Differences and similarities and will be about sporulation. So know when or when not sporulation will happen. RLA versus protein ribosomes, like where are they located? How is that specific colon ribosome? Transcription regulation from the complex DKSA PPGPP. Then know the best selector donor, best electron acceptor. What I provided for you in the exam is tower of power, which means you don't have to memorize that, but you have to know how to read tower of power. Which brings me to my next point, redox potential positive and negative. So know which one, know whether molecules on the top of the tower of power are redox negative or redox positive, and the same for those on the bottom. Remember, oxygen is on the bottom and the oxygen is the most redox positive. Which again brings me to my next point, electron transport chain. So who can be donor and who can be acceptor? Again, you have tower of power, but you still need to understand. Fermentation. Organisms that do fermentation, again, hint, they do not have electron transport chain. So thus, how do they create energy? How do they make ATP? And what is the purpose of that last dehydrogenase? If you remember from pyruvate, you will get lactate or ethanol with lactate and ethanol dehydrogenase. So know what's the purpose of that step, especially based on what we talked about reduction equivalence. Metal respiring organisms know the form of metal that can be respired, can be terminal electron acceptor versus form of metal which will be electron donor, like iron 2 plus, iron 3 plus. Microbial fuel cell. So what is anoxic? What is anoxic area? Who lives where and what's happening in anoxic versus oxic? Photosynthesis, so differences between oxygenic and anoxygenic, and the basic Rubisco characteristics. Microbiome and diet, most important diet change and its relation to firmicutes versus bacteroides. Genome scale metabolic model, when it's useful, understand what we can do with that. Denitrification, what is this type of process? Is it aerobic, anaerobic? Who is donor, who is acceptor, and what's the purpose of denitrification? And last but not least, I will just say nitrogen metabolism, GDH and GS-GOGAT system, high versus low nitrogen, alpha ketoglutarate in high versus low nitrogen, and full GS or glutamine synthase regulation at transcriptional and at the protein level, like who is phosphorylated when, who is uridylated and when. Section 2, those variable marks. Again, what I'm going to ask here, I will be focused on copper toxicity prevention and mechanism of regulation. So please look specifically, understand that specifically. And again, a little harder question on microbial fuel cell. Last but not least, 3 pathways for carbon fixation. You have to know 3 of them very well, key enzymes and key metabolites. And again, I'm staying in bioenergetic, exergonic versus endergonic, oxidation reduction, and what happens with reduction equivalent. Concept question 27 is the one that gives you 15 marks. And again, I can't tell you what exactly I will ask you, but recall metabolite labeling of metabolites with C13. Remember when we talked about that glucose can be labeled in position 1 and position 3, and based on that, we will see what is labeled and which of 2 pathways, EMP or EDD, is bacterium using. And there is a difference when we talk about heterotrophs that use glucose. What's happening when you have metanotrophs that use only methane, because methane has only 1 carbon. So know these things. And that would be all for this review session. Hopefully you will find this helpful. If you have any questions, let me know, although it's weekend, so let me know everything. We'll see you all on Monday at 1 p.m. I hope I didn't forget.